banana plug like that, and with a clamping. So that just gets clamped on like that. When we're doing the multi-electrode one, so this system can do 72 electrodes. That's electrode. And it does that through a multi-wire cable. There's 36 conductors in here. And this weighs about 18 kilos. So these yellow, these are the takeouts that this gets clamped. This gets clamped onto the takeouts there. And there's 18 on each of these cables. 18 of these takeouts. And then it connects through this box to the next cable. So there's 36. So there's 36 electrodes on each side of this box. And these takeouts are 10 meters apart on the cable. Yeah. And so it will spread out a total of 710 meters. 710 meters? What's that?
What did you say?
All the connectors will stretch out 710 meters. 72 minus 1 times 10. And let's see. So typically with that multi-channel system, multi-electrode system, you can see 1/6 to 1/7 of the whole length.
1/6?
Yeah, so you can see 100 meters. 100 meters. In resistive conditions, as you saw in the work that Doug was doing, it will see deeper. So it will see 150 meters.
150 meters?
Yeah. In conductive conditions, it may only see 70, 80 meters. Conductive in low resistivity. Let's say in 100 ohm meter upper layer, all the current might get focused in the 100 ohm meter layer, right?
Okay, you can draw.
That's what that one here, right? Yeah. If this is too conductive, 100 ohm meters, then it may not see as deep. So if that was 100, this isn't important for this right now. I was just pointing it out. So here, the system you can look, Kevin? Oh.
I was focusing on you. So
okay, we'll get that back there again. So now I have to move it up on the screen there. So for tomorrow, I'm going to show you how we'll use this system for just doing 1D, and that is the 4 electrode survey.
So 1D, one electrode.
You can see on here current CAB, which we've been working with all along. There's where the potential voltage is measured, MN. So these banana plugs will go into AB for the current electrode and MN for the potential voltage electrodes. Some of the other features, so this is the monitor, we'll bring it up on-off switch.
ပိတ်မဲ့ဖွင့်မဲ့လုပ်ပါမယ်
It can use an internal battery to transmit. So TX is transmitter,
TX က transmitter လို့ခေါ်ပါတယ်တဲ့
RX is receiver,
receiver တဲ့
and so you can put a 12-volt battery in a car battery to make bigger currents,
ကား battery နဲ့ join ပြီးသုံးနေရပါတယ်
or it can last a long time.
ဘို့တော့အချိန်ကြာသုံးရအောင်
Let's see if I go through that or not. Let's just turn it on and go. That's the menu window that comes up when you start.
အဲ့ဒါမြင်ရမယ့် screen ပေါ့နော်ကျွန်တော်တို့ screen မှာ
Whatever has those brackets around it is what the keystroke will work with.
key question mark နဲ့
Key.
နေရာကကျတော့
Yeah, the keys here.
အဲ့မှာ key မှာနှိပ်ရမယ်နေရာပါတဲ့
So I just cursored across, arrowed across, so now it's on setup.
setup mode တိထားတာပါ
And then there's memory and sequence, whatever the sequence is. So I'm just going to show you what we'll do tomorrow, because we have so many people. It will be easier for you to see it here today, and then you'll know what we're doing tomorrow.
ဒီနေ့ကျတော့ဘယ်လိုလုပ်ရလဲဆိုတော့ဒီ camera နဲ့ဆိုတော့ပုံမြင်ရတာပေါ့နော်လူအများကြီးဟိုမှာကြောက်ရအောင်အုပ်ပြီးချက်ရတယ်ဒီမှာမြင်ရတော့
That's the enter button right there.
enter ရှိမယ်
And so you can set it into different modes.
mode မျိုးမျိုးပြောင်းလို့ရပါတယ်
The standard mode is for just doing single measurements at a time.
ဆိုတော့တစ်ခုချင်းစီတစ်ချိန်နဲ့တစ်ခုချင်းစီလုပ်မယ်ဆိုရင်တော့ standard mode လုပ်ပါတယ်
Or I could arrow through. Let's see. I should be able to go here. Oh, okay. Even I get confused. I can't see where it is right now. Where is it?
The arrow?
Oh, it's still on mode. Okay, yep. So I'm arrowing over to change.
change ကိုတော့ပြန်ပြလိုက်ပါတယ်
So these are the other modes. When we're doing our 2D survey, we'll have it on automatic
2D
sequence.
survey လုပ်မယ်ဆိုရင်တော့ automatic set ကိုတော့ sequence ကိုပါပါမယ်
And we'll probably never use those two because
အောက်ကဟာじゃတိတ်မတော့ဖြစ်ပါဘူး
it's not needed for the work that we're doing 1D and 2D.
1 0 2 0 3မဲ့ခါလောက်မဲ့ခါじゃဒီတစ်ခုအောက်ကနှစ်ခုအမလို့ရပါဘူး
So we'll stick with the standard mode right now.
ကျွန်တော် standard mode ပဲပြန်ထားလိုက်ပါမယ်
And options, this is the options menu.
ဒါ option menu မှာ
So for our standard mode of collecting for our vertical electrical sounding,
ဒီ particle တောင်းလိုက်လို့ sounding လုပ်တဲ့ခါကျတော့
you can't see but there's a cross in here. So it's going to average a set of readings over approximately 2 or 3 seconds. It's going to average.
average
So this unit will collect, is doing continuous monitoring of the voltage,
ဒါရှောက် set
And the
လုပ်ရတာ
current.
ပေါ့နော်
and it averages those values over a period of time.
ဒါ average ပေါ့အချိန်ပုံမူကြည့်တော့ average ပြန်ပြန်တက်တာ
If this is instantaneous,
instantaneous
yeah, instantaneous. What's that? What's the Burmese word for that? Or the Myanmar word for that?
Instant.
instant
Instant.
အစ
Yeah.
နဲ့စနဲ့လောက်ရမှာစနဲ့တောင်းလို့ရတယ်
So that's a different setting. It just takes the last 4 measurements.
ဆိုတော့ကျတော့တိုင်းတာခြင်း၄ခုလုပ်လို့ရမယ်
Yeah. So whereas the average one that we have it set for, it takes it over about 4 seconds, and it's probably measuring 200 measurements or something like that.
ဆိုတော့သူကအချိန်ထဲမှာပဲဘယ်နှခုတိုင်းအများကြီးတိုင်းလို့ရတယ်တဘောပြောတာဖြစ်တယ်
And then you have a choice of changing it for unsigned or signed voltage. So this is absolute value.
ဒီ unsigned နဲ့ sign ရှိမယ်တဲ့
Do you know mathematically what absolute value is? There's no minus or plus.
သူက unsigned ကျ minus တွေ plus တွေမရှိ
So
ဘူး
it doesn't matter which direction the voltage is in. It's just a single positive value.
positive တစ်ခုပဲပါတယ်ဘယ်ဘက်အရေးကြီးတာဘယ်ဘက်
So you would just set these two before you ran the survey.
survey လုပ်တော့မယ်ဆိုရင်အဲ့ဒါကိုယူရပါမယ် choose average
Yep, average and
unsigned average နဲ့ unsigned ကိုယူရမှာဖြစ်ပါတယ်
I can't see, is it working its way through there yet?
Yep.
Okay, so to start a survey, we've got that all set up. We're just going to hit start. I don't know if you can see that or not.
so start ကိုနှိပ်လိုက်ပါမယ်
That says start. And let's see. Oh, I can't see it right there. We've still got one more. The units are in meters,
unit က meter နဲ့ထွက်ပါမယ်
not feet.
feet လည်းရှိပါတယ် feet နဲ့ meter နဲ့ယူလို့ရတာ
I can't even see what's set up. Memory, average, stack, start. So,
Stack.
oh, and just a sec. Where was array? Can you see array on there? If I,
Not here.
yep. Okay, just a second. And let's go to setup. Come on. These keys are difficult to push. You sort of have to roll your finger on it.
Oh.
Okay.
အဲ့ဒါအဲ့ခလုတ်တွေကနှိပ်ရတယ်နဲ့တော့လေလက်ချောင်းနဲ့နှိပ်
Name, position, stack. Oh, I think the array's down here, so I have to go down to the.
Options. TX timers. EI array. Clock.
Oh, okay. I want the EI array.
Or L array? Not sure.
EI array. Come on, get back up there. I forgot to set the array type. So Doug was showing you a Wenner array or a Schlumberger array up here.
ဒီမှာကျတော့ when array နဲ့ Schlumberger array ကိုပြထားတာပေါ့နော်
I think you were in, weren't you?
That one?
it is for it sorry
Oh yeah, there's under there.
So that was the Schlumberger array there, where you leave these at the same spot. You leave the potential voltage electrodes at the same location, and then move the current electrodes out.
Schlumberger array မှာကျ M နဲ့ N ကိုမရွှေ့နေတိုင်းထားမယ်ပြီးတော့ A နဲ့ B ကိုရွှေ့ပါမယ်
Or the Wenner array where everything is the same distance apart and you move them together when you're doing your
when
measurements.
array ကျအကုန်ပြန်ရွှေ့ရမှာပေါ့နော်
And it's set for Schlumberger right now, if I remember correctly. Okay.
Full dipole, put the
Is it still going down there?
Wenner.
Let's do a Wenner first because that's easier to understand.
Yeah.
So I don't know if you saw I selected Wenner array there. And then I go to start, hopefully. So now it's looking for some information from you as to what your measurement is going to be. So when we do a Wenner array, we usually do it around the 0 point. So here's 0 right here. M, N are a certain distance apart. And then A to M is the same distance. N to B is the same distance.
when array စတော့မယ်ဆိုရင်0ကိုလည်းမှာထားပါတယ်ထားပြီးတော့မှသူရဲ့အကွာဝေးအတူတူပြန်ထားရတယ်
So we've set the midpoint to be 0.
ဒါဆိုအလဲ number ကိုတော့0ထားပါမယ်
The same as you were doing with the notebook there. And there's a y value, but the y is always 0 because we're just working in one dimension.
y ဆိုပါပါတယ် y ကတော့0ပဲဖြစ်မှာပါဆိုတော့ကျွန်တော်တို့ 1t ပဲလောက်တဲ့အတွက်ကြောင့်မလို့ 1t method တောင်းတဲ့အတွက်ကြောင့်
What's that got on there now? So it didn't roll there. And now here's the number that you have to put in to decide what you're going to do. So before you go and do a vertical electrical sounding, you have to decide what separations you want to do. And it's usually done in a logarithmic scale.
So down like sounding look to me, so no, Huawei to the map, not Huawei and no less, right?
So you versus the log of your distance or your separation, I guess it is.
Yeah.
So typically, everybody is familiar with a log scale. Typically, what we
Log
would
scale.
logarithmic scale. So
Yeah,
we
I
would
think so.
we typically, if we were doing a logarithmic scale and we had quite a bit of data to collect, we go like distances x equals 1, 2, 4, 7, 10, 20, 40, 70, 100. Right, that's how that would sample the data set fairly well, rather than doing it every like 1, 2, 3, 4, 5, 6, 7, right? We'd more typically do it like that, 1, 2, 4, 7. Because those are about equal distance apart. So it'll be 1, 2, 4, 7, 10. They'll be approximately the same distance apart on a logarithmic scale. Not quite.
Scale.
So I'm going to start off, AB divided by 3 is, on the Wenner array, it's AB. That's the distance, so 1/3 of it is the distance right there. Okay, so 1/3 of it is the distance right there. And I just set this, I'm setting this one as 1 meter, so that we're starting off with 1 meter between the two inside electrodes.
So to AB go to 3 nem xa when I read my job also 3 bay to be mìnhจะ 1 meter ထားလိုက်မယ်
So this unit is smart now. It knows that what the next thing, when I push this button, it's actually going to be entering a number 1 or a decimal place 2, 5, 6, 7, not the other things that are on there, okay? So I'm hitting 1, enter. So now it gives you the positions of the electrodes that you have. The current A is at minus 1.5 meters. Current B is at 1.5 meters. The potential voltage, that's M, is at minus 0.5 meter, and N is at 0.5 meter. So at this point, you'd go and you'd put your electrodes and make sure you had them all in position. You'd actually plan this out before you did the survey. Okay, so you've got everything hooked up now. You have 4 wires running to the electrodes, and then you do your measurement. Well, so you're saying that's good?
1.5 meter ပြောတာပေါ့
So now what this system does is it checks and sees that you have good contact with your electrodes. So we don't have good contact with the electrodes because we don't have electrodes in right now. But this should say maybe 2 kiloohms.
So ဒါကချိတ်ဆက်မှုကောင်းမကောင်းဆိုပြတာပေါ့နော်
Yes,
ကျွန်
that's
တော်မချိတ်တော့မချိတ်ထားတဲ့အခါကျတော့မပြဘူးပေါ့
2,000 ohms. You want to be in that order, 2,000 to 5,000 ohms. We'll pour water, we'll bang the stake in further to make sure that we have a good connection.
2000ကနေ9000ထိ resistance ဥစ္စာကိုရချင်တဲ့အခါကျတော့ဒီလောင်းတာတော့အဲ့တေချာဟိုဒီကြီးတဲ့ကိုရိုက်ထည့်တာတော့တေချာလောက်အောင်ပေါ့နော်
And some of you that are near the front can hear this going click, click, click.
You hear the sound?
Did anybody hear the sound when it was going click, click, click? So it was testing the potential electrodes. And of course it found the potential electrodes, we don't have them hooked up either. But this one should be in the same, similar, 2,000 ohms, 5,000 ohms. And that, if you're happy with those, then you do your measurement. If you're not happy with them, then you have to reduce that contact resistance between your electrode and the ground. You know what it does like that?
I don't know how to say
So this has to be connected to the soil electrically very well. And it does that by the soil particles touching it. If the soil particles are dry, it doesn't connect very well. You have to pour water on it, maybe salt water on it, bang it in further, drive it down further.
So electrode time ကိုကြတော့မြေကြီးနဲ့ဓာတ်ရိုက်ထိတွေ့ထိဆက်မှုရှိမှရမှာပါเนาะသူကအဲ့ဒါမြေမှုန်တွေကခြောက်နေဆိုရင်တိတ်တော့စီမကတ်ဘူးမထိဘူးဆိုရင်เนาะရေလောင်းရတာတော့စားရေလောင်းတာတော့လုပ်ပေးရပါတယ်ဒါမှမဟုတ်လည်းနည်းနည်းဟိုအနက်ကြီးပြန်ထုထည့်ရတာတော့ထပ်လုပ်ပေးရပါတယ်
So now, keep your eyes on this very quickly. It's going to go very quickly. You're going to see the voltage and the current, and it will actually calculate the apparent resistivity for you too. Unfortunately, the people that made this instrument, in all their wisdom, don't allow you to stop the screen and put the numbers and write the numbers down. So what we often do is just take a picture of it.
So သူက screen ကနောက်ဆက်ပြေးနေမှာအဲ့လိုမျိုးဆိုတော့ဓာတ်ပုံရိုက်ဖို့ဆိုရေးဖို့အချိန်မပေးထားတော့မြန်တဲ့ခါကျတော့ဓာတ်ပုံမြန်လေးရိုက်ဖို့တော့သူကဘာပြမလဲ voltage ပြမယ် current ပြမယ် apparent resistivity ပြမယ်အဲ့လိုမျိုးဆိုတော့
But it will offer you the opportunity to then save the data onto the instrument.
အဲ့သူကကျတော့ data တွေ save လုပ်ထားဖို့တော့သူကချိန်မှသိထားပါတယ်
No, it's still going click, click, click. So it was still going click, click, click because it was trying to get that measurement. So it's using 46 volts. There's your row VI. Q's the quality.
I နေပေးမယ်
Oh, look at that. It stayed for a long time. We actually got to look at it.
မြန်တယ်ပြမြန်တယ်ပါနော်
So now we have the choice of storing it. So this unit allows you to store up to 44,825 pieces of data. When we're doing our 2D surveys, we'll be collecting somewhere between 1,400 and 3,000 data points.
So သူကအဲ့ data points ကိုကြာဒီမှာ4000ကျော်လေးပေးထားတာပါကျွန်တော်တို့ 2D စမ်းသပ်မှုလုပ်မယ်ဆိုရင်တော့အဲ့1000ကျော်1400နီးပါးအဲ့ data တွေကိုစုထားမှာဆိုတော့လေ
But when we're collecting this vertical electric sounding, we're only collecting one data point at a time. If there's any electrical engineers here or people who understand electrical engineering,
electrical engineering ကိုနားလည်လို့ရှိလားတဲ့ဒီ point မှာ
and computers, it stores it in a stack. So it starts at the bottom, and the bottom number is 0.
အောက်က0ကနေစပါမယ်
And if you're not comfortable with that, you can skip 0 and you can save it in position 1, so that when you collect 100 data points, when you download it, you don't have to save from 0 to 99. You can save from 1 to 100. See if everybody understands that.
သူက0ကျတော့ကျွန်တော်မမှတ်ဘူးပေါ့နော်မမှတ်တဲ့ကကျ1နဲ့စမှတ်မယ်ဆိုတော့1နဲ့ဆိုတော့1နဲ့မှတ်မယ်ဆိုတရားသိမှတ်လို့ရမှာပေါ့ပြောနေတာ0ကျတော့ဘာမှဥစားဘူး point နံပါတ်1နဲ့မထားဘူးပေါ့
So right now, because I already have some data on there, it's suggesting that I should save it in position 3.
3မှာ save ရမလား position 3မှာ save ရမလားဆိုတော့မေးတာပါ
So now it's just asking me, okay, there's already some data there. Are you all right to overwrite that data?
So data ရှိပြီလားအဲ့ပေါ်မှာ overwrite what do we mean by overwrite?
It's going to wipe out, erase the other data point, and put this new point in.
So overwrite ကကြတော့ဒီရှိနေတဲ့ data ဟောင်းကိုဖြတ်ပြီးတော့ကိုယ့်ရဲ့ data အသစ်ကိုဝင်မယ်ပေါ့အဲ့လိုပုံစံမျိုးလား
So if I say, you can see it's saying no right now.
no လို့ပြတာလည်းတွေ့မယ်
So if I do my enter, I'm going to say no, I won't save it there. And I can then put it in a different spot. So I think from 7 on, it'll save it.
7မှာ data store ဖြစ်သွားပါပြီ
So it said 7 was a clear spot, I could save it.
7ကလုံးဝဟို data ဟောင်းကိုဖြတ်ပြီးတော့ကျွန်တော်တို့ data တစ်ထည့်လို့ရပါပြီဆိုတော့
So then what we're going to do So we move to our next point.
not the thing ဟာ
So now if we did a move, it's going to shift this whole thing this way. But we don't want to do that because we're not trying to do a 2D survey. We're trying to do a survey straight down.
So we're move
So we're going to put a new point in. Or if we wanted to collect some more data at the same point, we could say okay, and we'll collect the data at the same point. Some people, especially with the system that Kevin used, you get a single measurement. There's no averaging. You just have a voltmeter and you connect it to your electrodes and you get one reading, no average.
No average the Kevin don't get a average voltage
This one's averaging about 200 readings, so you get a good average.
Average
But some people like to collect at least 4 points at each spot. At each location. And we're not going to do that. So we're going to choose a new position. So we're not going to move from the midpoint. This is going to stay at x equals 0. We're not changing y. And so now our original measurement was done with the separation 1 meter. Now we're going to do 2 meters. And so now it's telling us these are the new positions. The current electrode A is going to be at -3, current B at 3, potential -1 M, that's the M electrode, and then the N electrode at +1.
So that the position at the
So now they're all 2 meters apart. We get our electrodes, we move them into position, we hook the wires, and we're ready to do our next measurement. Okay, and so that's how this system works. With the system that we'll have, that Kevin has built, it's very similar, except that you're using a voltmeter instead of this doing the automatic measurement for you. Then one other thing that we do when we're in the field, if we're doing a vertical electrical sounding, is we also do a sounding 90 degrees rotated. And so that helps you a little bit more understand the 3D ground problem as opposed to just doing it in one direction. Yeah, but we won't do that for tomorrow, but that's enough. You've seen how this works and seen some of the stuff. Tomorrow you'll get some hands-on and you can actually do it yourself. Anything else, Kevin, Doug, that you want to say on that?
Probably just let them know about
So tomorrow we'll meet here at 9. And you should wear clothing that you can bend over and bang in stakes, stretch wire, etc.
And then Max, what is the golden rule of safety when it comes to DC resistivity?
Yeah, we'll do a little health and safety.
Okay.
And
Always on one?
Everything's going to be turned off and communicated before.
Yeah, we're still, Doug's going to talk a little bit more, but we will do a health and safety, a short health and safety session tomorrow, because if you're putting 2.5 amps in and 600 volts, then there's a possibility of shocking yourself. Okay, that's good. Doug? Do you want the HDMI cable?
Oh, okay.
Sorry? He's waiting for your help.
I didn't even offer some help. Having some trouble. Get to the
Yeah, that was a great idea.
And you did it before.
Again, I have the screens, but it's nothing like actually watching the stuff change. You got 20 minutes. Oh, you have a computer. Were you hoping you were going to do something else in your computers?
We'll see how they're doing.
Yeah, well, they're packing up.
Wait,
Attention.
so how many people have managed to get the 3-layer done? Or
3-layer sounding or
3-layer sounding. Oh, good. That's good. So what I will do is just go over part of, let's say, the first question, just so that everybody is familiar with what we're asking. And then for homework tonight, you can read, look at the 2 apps, both the 2-layer and the 3-layer.
Yeah, exactly. Layer 2 or layer 3 or layer 3 apps ko nene ji tha bo nene yin ni twa aw le. Exactly na.
So for question 1 for the 3-layer app,
3-layer app ye question number 1 ko twa ba me.
it says H1 is 10 meters,
H1 at 10 meter lo pi tha ba le.
H2 at 5 meters,
H2 ka 5.
row 1 is 500,
Row 1 ka 900,
row 2 is 50,
row 2 ka 50,
and row 3 is 500.
row 3 ka 500.
So we have a conductive layer. Let's just look at the model.
Model ko ji ba me.
So here's the model. We have a conductive layer here and something that's much more resistant.
So တော့အဲ့ကြားထဲမှာရှိတဲ့အလွှာသေးသေးလေးတွေဟို conductive ဖြစ်တယ်ပေါ့စီကြောင်းကောင်းတဲ့အလွှာဖြစ်နေတယ်။ကျန်တဲ့ဘက်ကကျ resistivity မြင့်နေတယ်
So what I'm asking you to do to start with is to fill in this table.
။ဘာနဲ့စစေချင်လဲဆိုရင်ဒီဇယားကိုဖြည့်စေချင်ပါတယ်တဲ့
And in doing this, you'll get a good sense for the relationship between the length of the array and how deep you're seeing.
။ဆိုတော့အဲ့ဒါကိုလုပ်ချင်ရဖြစ်ပါအောင်ဟိုအာယုံခံသိရှိလာနိုင်မလဲဆိုတော့ဗာလဲဆိုတော့အဲ့ဘလောက်ခွာဝေးဘလောက်ထားရင်ဘယ်လိုမျိုးဘလောက်နဲ့ထိသွားလိုက်နိုင်တယ်လဲဆိုတာကိုဟိုနားလည်တော့ပေါက်သွားမှာဖြစ်ပါတယ်
So you're asked to do, let's see, AB upon 2 is equal to 5.
AB
That's question 1. So it's the table.
Yep.
And something that you can do these. Whoops, what happened to where?
Did yours go off there? Or what?
Mine just has lost the
Cable.
cable.
That's still on up there.
So those are just the shape.
But your screen is not. Well, no, the screen is not.
What?
It might be running low on battery or something.
Oh,
There you go.
I don't know.
So if we click on these numbers here, we can actually make them what we want.
ဒီမှာနံပါတ်တွေကိုနှိပ်ပြီးတော့ကိုထည့်ချင်တဲ့နံပါတ်တွေထည့်လို့ရပါတယ်
So if I click on this number, So sometimes the slider bar doesn't give you quite that number. So then you can click on this and print the number in.
ကျွန်တော်ဒီမှာရွှေ့လို့ရတဲ့ဘားလေးတော့ပေးထားတယ်။ဆိုင်ရွှေ့လို့ရတဲ့ဘားလေးဆိုရင်လည်းကျွန်တော်တိကျမရနိုင်တဲ့ခါကျတော့အဲ့မှာကိုတိကျချိန်ချင်တဲ့နံပါတ်လေးတိုက်ရိုက်ရိုက်ထည့်လို့ရပါတယ်။
And if that doesn't work, which it just didn't, just do as best you can with the slider bar. There seems to be a little bug. Just a second. There we go. So here I just left it at 4.5. You should be able to type in the number, but somebody else, it didn't work, and it didn't work here, so I'm not sure. We'll take a look. Yeah. So just get close. If instead of 30 AB upon 2, you have 31.5, that's fine.
31.5 to
close. The idea with this exercise is that if we look at small AB upon 2, oopsie. So small AB upon 2, and then we look at the currents, we see that they're mostly up here, and that the apparent resistivity was just close to 5. So that's exactly what you
Current
get.
resistivity of 5 လောက်ဒီပါလောက်ရှိမယ်။ပြီးတော့သူကနီးနီးကပ်ထားတဲ့အတွက်ကြောင့်မလို့အဲ့ raise ကလည်းအဲ့ပေါ်လောက်ပဲသူဖြတ်
So this comes up to be equal to the resistivity of the top layer.
So ဒါဒီဘာကိုပြလဲဆိုတော့ပုံစံတော့မှရှိတဲ့ resistivity တစ်ခုလောက်ကိုပြတာလောက်ဖြစ်တယ်
And then you're asked to just make the array continually larger, look to see what the apparent resistivity is, and make a connection with the currents down here.
So ဒါမှ AB ရဲ့အကွာဝေးကိုထည့်ကြည့်ပြီးတော့လောက်သွားတဲ့ခါကျတော့အောက်ကို net တက်ကြည့်ပို့ပြီးတော့တိုင်းရနိုင်တယ်
So the rest of the other questions in here are kind of similar, but they're all designed to make you think about what is happening.
So ဒီမှာပေးထားတဲ့ပုံစံတွေကတော့လည်းဒီခုနဲ့တစ်ခုကတော့တိတ်မကွာမလှပါဘူးဒါပေမဲ့အဓိကကဘာလဲဆိုတော့ဘယ်လိုအဲ့လိုရွှေ့ပြီးတိုင်းသွားရင်ဘယ်လောက်ထိဘယ်လိုပြောင်းလဲသွားတယ်ဆိုတော့ကိုယ်တိုင်နားလည်စေချင်လို့စီစဉ်ထားတာဖြစ်ပါတယ်ဒီ question
Can I ask if are the questions clearly worded so that they're understood?
So ဒီမှာရေးထားတာကအင်္ဂလိပ်လိုရေးထားတဲ့ခါကျတော့လေ question ကိုသူဖတ်လိုက်ရင်နားလည်နိုင်တာလို့နားလည်တာပြောရတယ်
Okay. So that's your homework for today. So exercises for the 2 apps that you've used. So they're easy exercises. You just go in, you fill something in, but you think while you're doing it, while you're looking at the pictures, and it kind of helps understand what the DC resistivity experiment is.
ဒါတော့ဥစားပေါ့အင်္ဂါတွေပေးလိုက်တာပေါ့နော်အင်္ဂါပေးလိုက်တဲ့ဆိုတော့ကလည်းဒီနံပါတ်တွေထည့်လိုက်တဲ့ data တွေထည့်လိုက်ပြီးတော့ဘယ်လိုထွက်လာတယ်ဆိုတော့ဒီထည့်လိုက်ထွက်လာတာတော့ပဲမဟုတ်ဘဲနဲ့ဒါကဘယ်လိုဖြစ်လို့ပြောင်းသွားတယ်ဆိုတော့နားလည်မှုပေါ့နားလည်နိုင်အောင်ပေါ့အဲ့ဒါစူးစမ်းပြီးတော့နည်းနည်းလေ့ကျင့်ပေးပါ
Okay, so that's maybe that's enough for today.
ဒီနေ့တော့ဒီလောက်ပါပဲ
So again, for those people who were unsuccessful with downloading the apps, please try them tonight using Binder and at home. And then tomorrow we'll go to the park, we'll collect some data, And then we'll bring the data back and plot up an apparent resistivity curve.
So ဒီမှာကျွန်တော်တို့ data တော့ကောက်မယ်ကောက်ပြီးတော့ဒီမှာ parent resistivity ကိုဒီမှာပြန်လုပ်ကြမယ်ပေါ့နော်
So fill out the two.
ဒါလုံးလို့မရတဲ့လူတွေလေဒါလုံးလို့စူးစမ်းပြီးဒါလုံးကြည့်မယ်ဗျာဒါမှမဟုတ်လဲ binder နဲ့တစ်ချက်ကြည့်ပြီးပါ binder ကြရာယူရရတယ်
So fill out the two questionnaires, sign your name, and bring them back in tomorrow.
ဟုတ်ပါတယ်ကိုနည်းနည်းရေးခဲ့ပြီးတော့လေဟိုလက်မှတ်ထိုးပြီးတော့နာမည်နဲ့လက်မှတ်နဲ့ထိုးပြီးတော့ပြန်ပေးရမှာပေါ့နော်ညလုပ်ပေးပါတယ်
Any questions?
Question လေဒီ question လေးမေးခွန်းနေလေ So both paper both question set
Yeah, there's for the
DC2 layer foundation ရဲ့ DC3 layer sounding ရဲ့ DC2 layer foundation မှာကျွန်တော်တို့3မပါဘူးထည့်ထားတယ်DC3 layer sounding က all of them all
Yeah.
အကုန်လုံးပါ
They're easy questions.
သူကနည်းနည်းလွယ်တယ်မေးခွန်းနေပါမယ်အဲ့ဒါအင်္ဂါပါ
One problem can be that I saw stuff like this now. I think I'm going to start more maybe simple and shorter. A little long. And also like if I set the axis.
I'm using
There's problems with this. First,
I went to the training.
So you're going to.
That long speaker. I was and the trainers they speak with the American speaker. I'm not a native speaker. So that consider me as a native speaker. I'm a local. So that's pretty hard. No, I mean like speakers. Like when they are talking to each other, when I look at them, I don't understand why they're talking. And they use slangs, they use idioms, and like that, you know. But not this training. What is that? I lost the way. I lost the way at the time.
Honestly, when I first came into this, that was like that.
Okay, and you have some food in the meeting. That we call seasonal meat rice. What's my name? My name?
Oh, there was so much.
Does he work then with this? So he's going to be at skill B. And then, are you also a TH?
Other TH.
I don't know. I thought. No, it depends on.
And another
Coco was going to be.
What
they work together? Have you collected data with
Takes a photo.
Syscal system နဲ့ပတ်သက်ပြီးဒါထောက်
This is how you're on the latest version.
And then, do you work with the inversion codes?
inversion ပိုင်းတော့ inversion ဆိုတာဒါပြန်